Hello everyone. Welcome to today's session. In the last class we have started with the module Z-Transforms. Today we'll continue with the concepts. There are few more properties of Z-Transforms. Let's discuss that. The first property is multiplication by n. What does this property say? If Z-transform of u of n, where u of n is a real value function we have discussed in the last session, is equal to u of z, then Z-transform of n into un is equal to minus z into differentiation with respect to z of the function u of z. This is the general formula for multiplication by n. Now the other type of property, which is an important property, that is shifting property of Z-transform. This shifting property consists of two properties. There are right shifting and left shifting. Now first let's discuss what is right shifting. If Z-transform of u of n is equal to u of z, then the right shifting of this Z-transform is given as Z-transform of u of n minus k, where k is the k are the constants from which tends from 1 to infinity, where k is, again the condition it's given as k is greater than 0. If Z-transform of u of n minus k, then its Z-transform is given as z to the power minus k into u of z, where k is strictly greater than 0. So if it's strictly greater than 0, we know that it's a positive integer. So this was all about right shifting. So the other type of property, and which is a very important property, this property mainly we are going to use in many problems, that is left shifting. If Z-transform of un is equal to u of z, then Z-transform of u of n plus k is given as z to the power k into u of z minus u naught minus u1 into z to the power minus 1 minus u2 into z to the power minus 2. This goes on until the last term, that is minus u of k minus 1 into z to the power minus of k minus 1. This k minus 1 corresponds to the last term of the series. That is, for example, if the series goes from u0 to u5, then the last k value is 5. So there are some particular cases as well for this left shifting, that is particularly if k is equal to 1, 2 and 3, then the Z-transform is given as Z-transform of u of n plus 1. That is, in place of k we have written it as 1. Then it is given as z into z to the power k is 1, right? So z to the power 1 into u of z minus u0. Similarly, if k is equal to 2, then it is given as Z-transform of u of n plus 2 z square into u of z minus u0 minus u1 into z to the power minus 1. That is for when k is equal to 2. Similarly, when k is equal to 3, Z-transform of u of n plus 3 is equal to z cube into u of z minus u0 minus u1 of z to the power minus 1 minus u2 of z to the power minus 2. Similarly, we can write it even for k is equal to 4. In k is equal to 4, the another addition of term, that is minus u3 z to the power minus 3, if when k is equal to 4. So this goes on for all the k values. So now we'll discuss few other concepts of Z-transforms, that is the initial value theorem. This is basically the values which we are finding in this initial value theorem are u0, u1, u2 up to u infinity, or you can write generally we can write it as u of k. So what does this theorem say? If Z-transform of un is equal to u of z, then the function u0 is given as limit where z tends to infinity, or we can directly write it as z is replaced to infinity into u of z. So this is the general form for u0. In generally we can write it as, generally means the value of this 0, or we can replace it by k, where k is a constant which can be any number. In that case it is given as limit from z tends to infinity into z transform of u of n plus k. So now let's use the left shift rule for the general form, that is when k is equal to 1. So when k is equal to 1, we get the value as u1. So what would be the formula for u1? The formula for u1 is given as limit from tending to infinity z transform of u of n plus 1. So now we have discussed right now the z transform of u of n plus 1 in our a few minutes before. So what does it say? It says that limits from z tends to infinity z into u of z minus u naught, that is z transform of u of n plus 1. Similarly, we have for k is equal to 2, that is u2 equal to limit from z tending to infinity z transform of u of n plus 2. It is given as limit from z tending to infinity z square into u of z minus u naught minus u1 into z to the power minus 1. Similarly, also we have for when k is equal to 3, that is we need to replace the z transform of u of n plus 3, and it goes on so on for k is equal to 4, 5 up to infinity. So now let's see what is the final value theorem mean. So the initial value theorem starts from 0, right? Whereas the final value theorem starts from the last term, and the last term is given as z transform of u of n. In the initial value theorem we started with u naught, right? So in the final value theorem we need to start with the u of n, that is the last term. Generally it is given as limit which tends from z to 1 where into z to the power z into minus 1 z minus 1 into u of z. So this is the required final value theorem. So these are all about the concepts related to the z transform. So now we'll start with the problems. So while doing the problems you will be clear about the concept and you will understand all the concepts clearly which we have discussed till now. So now let's start with the problems. Yeah, so this is the first problem of the z transform concepts. So the first problem says that find the z transform of n into a power n, also z transform of n square into a power n. So now let's solve for the first problem, that is z transform of n into a power n. So now for the solving of the first problem we need to know that in the question it's given the term a power n. So we need to recall all the concepts we have discussed in the z transform. In that this a power n comes in the damping rule. So what does the damping rule say? We have discussed the damping rule as z transform of a power n into un is equal to z transform of un where z is replaced by z by a. This is the damping rule. This is the first condition for damping rule. Similarly we have other condition as well. So but this condition fits to the question. So in this case the value of un is, we can see that n. So now we need to apply that condition. So we know that the value of un is equal to n. So now what happens to the z transform? It is given as z transform of n where z is replaced by z by a. We have also discussed the z transform of n. It is z divided by z minus 1 whole square. The z transform of n where z is replaced by z by a. So now what we need to do, wherever there are z terms we need to replace it by z by a and we need to simplify. So there is a z here, so it becomes z by a divided by z by a minus 1 whole square. So now we need to simplify this term. So let's keep the numerator as it is, that is z by a. So now let's solve for the denominator. We can use the identity a minus b the whole square. So what would we get? A square plus b square, that is 1 square, minus 2z by a, 2 into z by a. So now by further solving this we can get it as z square by a square. I am just taking the power outside, plus 1 minus 2z by a. So now here we can take the LCM as a square. So what happens when we take a square as the LCM? Z square as it is plus, so since the LCM is a square, we need to multiply 1 by a square, that is it becomes a square minus 2 into a into z divided by a square. We just took the LCM. So now bring this term to the numerator, that is we need to take the reciprocal of the denominator. A square becomes the numerator, z square plus a square minus 2az. So here we can cancel one a. So the final answer we get is z divided by z square plus a square, za, there is an a term, minus 2az. So this corresponds to an identity that is a minus b whole square, right? So we can write the final answer as za divided by z minus a whole square. So this is the required Z transform of n into a power n. So now similarly we need to find the Z transform of n square into a power n. So as we did in the first problem, same thing. Here the value of u power n is replaced by n square. So the identity of damping rule says that Z transform of n square into a power n is equal to Z transform of n square, where the value of z is replaced by z by a. So now we have discussed the Z transform of n square as well in the last video. So what does it say? The Z transform of n square is given by z square plus z divided by z minus 1 whole cube, where z is replaced by z by a. So now here the same thing, we need to replace all the values of z by a. So this becomes z by a whole square plus z by a divided by z by a minus 1 whole cube. So now just we need to simplify this. So now let's take the power outside, that is z square by a square plus z by a divided by, so now we can take the LCM inside only, inside the bracket. So what does it become? Z minus a by a the whole cube. So now again we can take the power outside for this term, that is z square by a square plus z by a divided by z minus a the whole cube divided by a cube. So now let's take the LCM for the, numerator, that is we need to take the LCM. So when we take the LCM, we need to let's multiply the denominators, that is a cube and z square into a plus a square into z divided by z minus a the whole cube by a cube. So now let's bring this denominator to the numerator by taking the reciprocal. Into a cube divided by z minus a whole cube. So now we can cancel this a cube. So the required answer that we get is z square a plus a square z divided by z minus a the whole cube. This is the required Z transform of n square into a power n. Let's get to the other problem. So yeah, this is the second question. Find the Z transform of cos h n theta and sin h n theta. So now what is this h? This h is an hyperbolic function. You might have heard this in your previous semesters, and hyperbolic trigonometric functions. So this question is there, right? This is a very important question. So you please make a note of this question. This might be can be asked in your exams. So yeah, please make a note of this, and this is a very important question. So in order to find the Z transform of these functions, we need to know what are the values for cos hyperbolic and sin hyperbolic functions. So now first we'll write that. Some of you might be knowing it. I'll write it. The cos h n theta is given by e to the power n theta plus e to the power minus n theta divided by 2. Please put this in a box. This is a very important formula. Similarly, sine hyperbolic function is given as e to the power n theta minus e to the power minus n theta divided by 2. Please make a note of these cos and sine hyperbolic functions. After this, we need to find the Z transform of these functions. Okay, so now let's solve this. Yeah, so now let's solve this Z transform. So here we can take some common terms outside. That is, this 2 is there, right? So it becomes 1 by 2. We can take this 1 by 2 outside, and we can use the first property, that is the linear property. That is, we can add the Z transform, we can split the Z transform inside. So how does this become? Z transform of e power n theta plus Z transform of e power minus n theta. This is by using the linear property. Again now, by seeing this e power n theta term, we can remember of another one Z transform general formula we have discussed, that is Z transform of e power an. So this is given as, we have discussed it, z divided by z minus e power a. So the same thing we are going to apply here as well. So in place of a, that is, we have theta. So wherever a is there, right, we need to replace it by theta. So now what does this become? It becomes Z transform of e power n theta is given by z minus z divided by z minus e power a, right? In place of a there is theta, so we need to write theta plus z divided by z minus e to the power, so n into minus theta, right? So the e power minus theta. In place of a we need to write it as minus theta. So that's it. Now we need to just simplify these terms. That's it. To get in order to reach the final answer, we need to simplify. So now just cross multiply and take the LCM. That is, we need to cross multiply minus e power minus theta plus z into e power theta divided by, we need to multiply these two, that is so again now multiply these two terms, z into z is z square minus z into e power minus theta plus z into z again z square plus into minus minus z e power theta divided by, again we need to multiply these two, z into z z square minus z e power minus theta minus z into e power theta. I'm just multiplying it. Minus into minus is plus e power theta into e power minus theta. So now add, there are two z terms, so it becomes 2z square minus, in these two terms this z is there, right? Minus z is common, right? So I am taking it out. I am writing the remaining terms, that is e power theta plus e power minus theta. I took minus z common outside, divided by z square minus z e power minus theta minus z e power theta, and this can be replaced by, so let's, by simplifying this, what we get, so I'll do it here, e power theta into e power minus theta. So bring this e power minus theta to the denominator. So what does it become? E power theta divided by e power theta. I bought this. We know that e power minus theta is equal to 1 by e power theta, right? So that's all I did, and we can cancel it and make it as 1. So I'll directly write it as plus 1. Okay. So now this is not it. We need to further simplify it. So if we observe this term carefully, so we can conclude, we can say that e power theta plus e power minus theta. This is similar to an hyperbolic function. In order to complete the hyperbolic function, we need divided by 2, right? Cos h of n theta. N theta is there, but here there is only theta. So we need to get the cos h of theta. So for that we need this divided by 2, right? So now let's bring that divided by 2 by multiplying and dividing by 2 for this term. That is 2z square remains as it is, minus we need to multiply 2 here into e power theta plus e power minus theta divided by 2. Okay, divided by the same term z square, and again in the denominator we can take z common. See that minus z, we can take it common, and we can multiply 2 as well there to get the hyperbolic function. That is e power theta minus e power plus e power minus theta divided by 2 plus 1. So we are just doing this multiplying and dividing by 2 for the sake that we need to get an hyperbolic function, so that we can directly write the hyperbolic function. Okay. So by further simplifying, what we get, minus 2z into, so this corresponds to an hyperbolic function, that is there is plus, right? So cos h into in power of e power, that is there is only theta. In case of cos h n theta, right, this n theta, that is the power of e, right? That only we are writing it. So here also we need to write the power of e. What is the power of e here? That is theta. So cos h theta divided by z square minus 2z, again there is plus, so cos h theta plus 1. So again in the numerator we can see that there 2 is common, right? Take that 2 outside and write the remaining terms, z cos h theta, z square minus 2z cos h theta plus 1, and cancel this 2. So this is the required Z transform of cos h n theta. So just see this whole sum again carefully. See all the steps clearly. I have done the problem by step. Otherwise this problem is generally completed by 4 or 5 steps. I have done this in brief and in an easy manner so that you can understand. Similarly, we are going to do it for sin h n theta. So now we are going to do it for sin h n theta. The formula for sin h n theta is given by, there is no change at all. In case of sin, in place of plus we need to write it as minus. And now again I have taken 1 by 2 outside and I have splitted the Z transform by using the linear property. And in last problem there was plus. So now it become minus. So now again we need to use the Z transform of e power an, where in place of a there is theta. So the same thing we are going to do it again. We are going to get it as z divided by z minus e power theta. So now minus z divided by z by e power minus theta. So the same thing we need to simplify this. I am going to do it quickly now. Cross multiply e power minus theta minus z divided by e power theta divided by minus theta. Multiply the terms, z square minus z e power minus theta minus z square plus z d power minus theta, minus into minus plus z square minus z e power minus theta minus z e power theta plus e power minus theta. So you can see that z square gets cancelled, and we can take z common. If we take z common, what are the terms remaining? E power theta minus, we took z common. In the last problem we took minus z common, right? So this minus we need to include in the bracket, divided by z square. Again we need to take z common in these two terms. Now minus z we can take it common, and we can write it as e power theta plus e power minus theta plus 1. This term becomes 1. So now again we need to multiply and divide by 2 for these both cases in order to get a hyperbolic function. E power theta minus e power minus theta divided by 2, z square minus 2z into e power theta plus e power minus theta divided by 2 plus 1. So this corresponds to a sine hyperbolic function, since there is a minus. So sine h of e power theta, right, divided by, and this there is a plus, so this is a cos h of theta plus 1. So again we can cancel this 2, and the final answer is cos h theta plus 1. So these cos h theta and sin h n theta hyperbolic functions which we have solved, you need to remember this. So make a side note of it, okay? So yeah, please make a note of these Z transforms, because these Z transforms again can be used in further many problems for solving, okay? Please make a note of these Z transforms.